A bazooka balun, more commonly called a sleeve balun, is a type of 1:1 current balun made by placing a conductive tube or braided sleeve over the outside of a coaxial feed line. It is highly effective at choking off common mode currents, preventing your feed line from radiating and distorting your antenna's pattern. However, because its design relies on specific physical wavelengths, it has strict practical limitations depending on the band you are operating on. The bazooka balun works by exploiting transmission line theory, specifically the behavior of a quarter wave shorted stub. Construction: a metal sleeve, often aluminum tubing or stripped copper braid, is slipped over the main coaxial cable. Connection: the top of the sleeve at the antenna feed point is left completely open. The bottom of the sleeve is electrically shorted to the outer shield of the main coax. The length: the sleeve is cut to exactly 1/4 wavelength of the target operating frequency, adjusted for the velocity factor of the dielectric between the coax jacket and the sleeve. When a common mode RF current tries to flow back down the outside of the coax shield, it encounters this sleeve. Because the sleeve and the outside of the coax shield act as a secondary coaxial line that is shorted at the quarter lambda mark, it presents an infinite impedance, a massive RF choke, at the open end. This forces the currents on the inside of the main coax to remain perfectly balanced, providing an elegant transition from an unbalanced coax to a balanced antenna like a dipole or the driven element of a Yagi. Because the bazooka balun relies on a physical quarter lambda length to create that infinite impedance, it is strictly a monoband device. Its choking effectiveness drops off rapidly if you move too far from its center design frequency. More importantly, the physical scale dictates where this balun is actually useful. It is highly practical for VHF or UHF bands. On the 2-meter band, a quarter wave sleeve is only about 50 cm long. For a 70 cm LEO satellite Yagi, it is a mere 17 cm. Here, slipping a piece of aluminum tubing over the boom's feed line is lightweight, cheap and structurally easy. But it is impractical for low HF bands. If you are building a resonant 80-meter dipole, a bazooka balun is generally a non-starter. At 3.6 MHz, a quarter wavelength is roughly 20 meters. Suspending a 20-meter conductive sleeve vertically from a feed point is physically unmanageable and incredibly heavy. For HF bands like 80-meter or 160-meter, broadband ferrite chokes like coax wrapped around an FT24031 or FT24043 toroid are heavily preferred over sleeve baluns because they provide high choking impedance across multiple bands without the massive physical footprint. The bazooka balun is frequently confused with the double bazooka antenna. While both use coaxial cable in their construction, the double bazooka is a broadband half-wave dipole made entirely out of coax, whereas the bazooka balun is strictly a feedline choke.